What's up, guys? So today we're doing a video on solving systems of rational equations. And this is actually nothing new because it's really just kind of combining some things that you know already. So we know that when we're solving a system of equations, what we're really looking for is where they intersect. And we solve those usually by setting the equations equal to each other, especially if there's just two. If you have two equations, we can figure out where these intersect by setting them equal to each other. So let's just do that. 1 minus x over x squared equals x minus 1 over 2x. If I want to know when two things are equal to each other, set them equal to each other and solve it. Well, this is a problem that we've been doing since the last unit. We're really just solving a rational equation. So really it's nothing new, but we'll go ahead and work this out. So we have to get a common denominator, which is going to be, the common denominator is going to be 2x squared. That's kind of what I want to look for in my denominator, okay? So this needs to be multiplied by 2, and this needs to be multiplied by x. Okay, so on the left side, I'm going to get 2 minus 2x over 2x squared. On the right, I'm going to get x squared minus x over 2x squared. Now, as I'm moving things left and right, I want to get everything on one side. I like to keep my x squared positive if I can. So since there's no x squared over here and there is one here, I'm going to move everything to the right because I want to keep it positive. Just makes it easier so you have to change the signs later. If you want to factor it and all that, it just makes it easier. So I'm going to go and put a 0 over here. I'm going to move everything over. So I'm going to keep the x squared. I'm going to add 2x to the negative x. I mean, this will be plus x now. And I'm going to subtract 2 over 2x squared. So there it is. So to solve this, to figure out when this will be equal to 0, remember what I really need to do is figure out what value of x would make the numerator 0. And to do that, I'm just going to factor this part. Let's just factor this. This factors as x plus 2, x minus 1. Okay, if they multiply to make negative 2, they add up to make positive 1. And when will that be equal to 0? If x is negative 2 or positive 1. So that's the answer. Okay, and I want to do another example just because sometimes they like to trick you. And so if we were to solve this one by setting these equal to each other, the common denominator here is just going to be x squared. So I got to get an x squared here by multiplying by x on the top and bottom. Okay, so I'm going to get x plus 1 over x squared equals x over x squared plus 1 over x squared. Now somebody's going to notice right now that there's something funny going on here. If you look at this, x plus 1 over x squared, if I were to combine these together, this would also be x plus 1 over x squared. So what I've actually got on both sides of the equation is the same thing. If you notice that right now, you can actually stop, because what this means is you're graphing the same thing. If I were to graph this and if I were to graph this, they would be the same graph. So if I ask the question, where do they intersect everywhere, okay? Everywhere except where they can't exist, which is 0, okay? So really the answer here is it's all real numbers except the excluded value of 0. I can't have a 0 in the denominator, okay? But the solution for the intersection here really is everything but that. So the solution, you could say x has to be greater than 0 or x has to be less than 0, but it can't be equal to 0. If you're using interval notation, you would say from negative infinity up to 0 and from 0 up to infinity. Okay, either of those. If you want to keep working this out, what will happen is, so this is going to become, this part right here, that would become x plus 1 over x squared. So if you didn't notice it yet, then once you've got these on both sides, if I were to subtract this over here, and if I were to subtract this over here, what I ended up with is 0 on the left side and 0 on the right side. If you have 0 equals 0, or anything equal to itself, the answer is going to be all real numbers, except you still have excluded values. You still can't plug a 0 in. They're not equal to each other at 0 because they don't exist at 0. So that's an important point. Okay, and one more tricky example, and it's not hard to work out, but again, just a little bit tricky. So if I were to set these equal to each other, I need a common denominator, so I'm going to use x plus 2. So if I multiply this by x plus 2 top and bottom, this is going to be 3x plus 6 over x plus 2. Okay, and you see I've got a common denominator, so if I subtract everything onto the left side, 3x minus 3x is going to cancel out. All I'm going to be left with is a negative 6 on the top and x plus 2 on the bottom equal to 0. Now what can I plug in for x that will make this whole thing equal 0? There's nothing. There is no x in the numerator, so there is no way I can make this equal 0. Okay, so my solution is all real numbers. I'm sorry, my solution to this is nothing. There's actually nothing I can plug in. There's nothing I can plug in for x that will make this work. We don't even have to take into account the excluded values because there are no solutions at all. So that's easy. You just say there's no solution. And that's it. If you think about the graph, we also know that this would have a horizontal asymptote. Okay, if you look at this graph, this would have a horizontal asymptote at 3, at y equals 3. So kind of like you'd have a horizontal asymptote up here that this graph is going to approach but never reach. And what is it equal to? It was equal to 3. Okay, so the reason this will never equal 3 is because that is actually the horizontal asymptote. So maybe you'll notice that right from the beginning, but a lot of times it's kind of hidden. You don't see it as obviously as that. So this is what you do. This will never equal 0, so there's no solution.